And next up is question 7. It says, find the distance from the point P with coordinates 1, 0, -1 to the plane described by this equation, -4x plus y plus z is equal to 4. Okay, and I've drawn a picture here. We have our plane and our point P, and our job is to find the distance from this point to the plane. Or put another way, we want to find the minimum distance between this point P and a point on the plane. Okay, now to start, I'm going to consider a normal vector to the plane, I'll call that n, and a point on the plane, which I'll denote as p sub 0. And now let's go ahead and form this vector p0p in yellow, and note that the distance we're looking for is this distance in blue. And if the angle between the yellow and the orange vectors is acute, as it is in the picture that I've drawn, this blue distance is nothing other than the scalar projection of p0p onto the normal vector. Okay. Now, if the angle between the yellow and the orange vectors is obtuse, okay, then the scalar projection, as we know, will be negative, but in absolute value, it will equal this blue distance that we're looking for. Okay, so in general, right, the distance from a point to a plane can be computed as follows. We take the absolute value of the scalar projection of this vector p0p onto the normal vector, which, as we know, to compute the scalar projection, we take the dot product of the two vectors and then we divide by the magnitude of the vector we're projecting onto. And here we're projecting onto the normal vector, so you see that division by the magnitude of the normal vector. All right, great. So now let's go ahead and apply this. So first thing we're going to need to find is a point P0 on the plane described by this equation, -4x plus y plus z is equal to 4. So put another way, I just want any ordered triple that makes this equation true. And to make things simple on ourselves, I'm going to set x and y to 0, and then that forces z to equal 4. So our P0 will be 0, 0, 4. All right, so then what about the vector P0p? Well, I want the vector whose tail is at the point P0 with coordinates 0, 0, 4, and whose tip is at the point P with coordinates 1, 0, -1. So you just subtract coordinate-wise, so 1 minus 0 would be 1 for the I component, 0 minus 0 is 0 for the j component, and then -1 minus 4 is -5 for the k component. So that's our vector P0p. How about a normal vector for this plane? Well, for that, we can just read off the coefficients of x, y, and z. So that's -4, 1, 1. And now I can just go ahead and apply the result from above. The distance from this point P to our plane will be the absolute value of this dot product divided by the magnitude of the normal vector. The dot product, well, it's going to be -4 plus 0 plus -5. So that's a -9. And then we divide by the square root of, well, in this case, 18, right? You've got to do 16 plus 1 plus 1. Okay, so then simplifying and taking absolute value, we get 3 over the square root of 2 for this distance. And that's going to do it for this video. All right, thanks so much.